welcome back. We're going to be building our API layer for our catalog service here. So the first thing we're going to do is add a new project to our catalog service folder. We're going to start with an ASP.NET empty, ASP.NET Core empty project, and we're going to come to our services, catalog service, and this one is going to be catalog.api. I usually use the default configuration here. We're eventually going to come back and talk about container support for running in Docker, even in development side of things, but we can add that after the fact. So let's keep our defaults for the moment. We're going to go ahead and add our project. And we want to set this now. We finally have a project that is worth setting as the startup project. Because everything we've worked on this one has just been class libraries. Okie dokie. So first thing we need to do is come in and start fleshing out our program.cs. Now we're going to be layering on some additional things in future videos around logging, exception handling, capturing performance metrics and things like that. So we're eventually going to be layering on more sophistication to our APIs here, but I want to start out with just a simple approach. Let's sort of work on getting the bare minimum up and running so that we can run some tests. But I do consider, because it's often an afterthought, that a bare minimum should include security. So we want to support secure endpoints, meaning that someone has to authenticate in order to be able to call our endpoints. My preferred way of doing that, pretty common practice, is to use an external authentication provider. In this case, we're going to use Firebase. And then what we need to do is what we're expecting from the client is a JWT that we can validate, and we know that they've been authenticated, who they are, and a few other bits of information. So with that in mind, what we're going to do is we're going to first of all add some dependencies on, say, the Firebase admin APIs so that we can authenticate our JWTs that are coming in via Firebase. So what we want to do is add a dependency here for Firebase admin. Okay, we got our Firebase added. And one of the first things that we can do here is in our app, as we're going through our builder, we want to add builder.services.add authentication. And we're going to have JWT bearer defaults. Oops. Basically, we need to configure our JWT authentication here. So we need to add a reference to our Microsoft ASP.NET Core Authentication JWT. Not sure if this guy's going to complain. Yeah, I figured he might complain because I have a .NET 8 project here. And it's probably trying to install the latest, which is 9. So I think we need to drop this back down to 8, whatever the last version is for version .NET Core 8. And that seems to have worked. Perfect. Now we can come back and fix this guy. All right. So what do we need to do? Well, we want to be able to authenticate the authority that the JWT was issued under. So we want to set the authority that we're going to validate against. And we're going to get that from our app settings. We're going to create a section in our app settings called JWT. That's going to have several properties, including the authority that we are validating against. And then we also want to set various validation parameters on the token itself. So when we're validating the token, to make sure it's a valid token, we want to validate the issuer. So we want to set that to true. And we're going to set the issuer again to our builder configuration get section JWT. Authority. So that's who we expect to be issuing it. And we want to validate the audience, which is also going to come from configuration. We'll have a property in our configuration called audience. And then we want to validate the lifetime of the token, meaning we want to make sure it's not expired. And then we're going to require HTTPS metadata false for now. So that's the basic setup. What we need to do is come into our app settings here and make sure that we actually add in our configuration options that we just created there. So what we want to do is have a section called JWT. Audience. And authority. So in order to wire up C# to use our Firebase account here, we need to come into service accounts and we need to generate a private key, warning us that it's not recoverable, so make sure we keep a copy of it. So I just downloaded it to my downloads folder, and I am copying it here. Let me bring it into, we're going to place it right in the root of our folder here, of our API project here. So in here we have the JSON file that was just generated for us. And now we can come back, and one of the things we want to do is we want to look up the authority. So off screen here, just because it has the private key in it, therefore I'm not going to put it on the screen, but what I'm grabbing out of here is in the JSON file, there's going to be a URL and also an ID, sorry, project ID. And the project ID is what's going to be the audience. And then the URL that we're going to end up using, sorry, just grabbing one more thing out of the file here. The URL that we're going to end up using here for the audience, and sorry, I got these backwards, my bad. In fact, that's perfect. The URL for the authority is going to be http securetoken.google.com / the name of our project. And the audience is going to be the name of our project at Firebase. So basically we have our audience and our authority set now. And the other thing we need to do is actually wire up and tell Firebase. So when we start our app, we need to basically start the Firebase admin side of things as well. So what we're going to do is during our build process, we're actually going to wire up, I'm just copying this to save a little bit of typing here. We're going to wire up, we're basically creating a Firebase app that is going to run, and we need to now pass it the path to all right, so now we've basically done a couple things. We've added authentication, and we've told the application how to validate our JWT tokens. And then we've added in the necessary configuration file that is necessary for the Firebase app to be configured and run for us. So we've got those pieces taken care of. Next thing we're going to add is support for Swagger. And in order to do that, first thing we're going to do is add a dependency here. we are going to look for swashbuckle.asp.NET Core, and we're going to install this guy. This will allow us to use the built-in support for having ASP.NET Core automatically generate this Swagger documentation and expose an endpoint that we can use for debugging purposes, a UI around the Swagger. So first thing we need to do is on our builder here, and we're going to services.add endpoints API Explorer, which is going to give us that debugging interface that I was referring to. And we also want to add the Swagger gen, which is going to generate the Swagger. And then under the app itself, we need to make sure we have app.use Swagger and app.use Swagger UI. A lot of people tend to wrap that on a if statement that says only in the development environment do we want to expose the Swagger UI. I personally like to leave it on, so we'll not wrap that. Next thing we're going to do is add support for cores. So we have to add a policy here. What we're adding is cores, and the way you add cores is you create a policy with a name, and then you can reference and enable that policy essentially. So I'll call mine cores app, and we are going to express what the policy is here. So we're going to allow any header, any method. We want to allow credentials, and we want to say with origins of localhost. So once we develop a front end, we'll need to update the API endpoints, the callers that we're supporting here, the origins. But for now, that'll be good. And then we have to actually enable our policy. So once we've created it, we have to actually use it. So we're going to say app use cores. Oops. And reference the name of the app. All right, so now we've got cores added. Now, during the prior videos, we were talking about how for every single request that comes up to the server, we want to create and instantiate for the lifetime of the request this thing called a user session, which is going to give us access to information about who's made the request, who they are, etc. So for that, what we're going to do is add some custom middleware. And so we can say app.use and in our custom middleware here, what we want to be able to do is take the ID token that we've received in the authorization header. So, sorry, this is going to be nullable ID token. We want to get this from our request headers. So we're going to get the authorization request header value. And what we ultimately want to produce is an iUser session. Let's go ahead and add our dependency here. Reference. All right. Now, if the ID token that we have received is not null, that means that we want to first thing we need to do is just strip out the token header itself is still going to have be preceded with the word bearer in a space. So we want to remove that. Simple replace operation here for bearer space. We want to replace with string.empty, and that'll be our actual ID token. And what we're going to do is we're going to have a JWT security token handler. And what we want to be able to do is read the actual JWT value, read the actual string token into an object that represents the overall token itself. And from that token now, what we can access are the various claims that are in the token, which we're going to use to fire up our user session. So our user session is going to get set to we're going to, from our dependency injection, get the iUser session. It won't have the user set on it yet. It's just going to essentially be an empty user session, and what our goal is to set the actual user on that. So we are going to use the method we had on our user session for load session, and what we're going to pass into that are the different claims that we need. So we're going to get the subject claim, and we're going to pass that in, right? So just as a reminder here, so we're taking in the external ID, the first name, the last name, and the email. The external ID is going to be in the subject claim. And then we're going to grab the given name, and next we're going to grab our surname, and then finally we are going to grab the email address. Notice I got too many parentheses there, sorry. So finally we're going to grab the token where the token type is email. So as a reminder, if we just jump into this here real quick, what we're doing is we're just loading up the session here. So if we come into our implementation of this, on our concrete implementation, what we're going to do is we're going to take this external ID that came in. So this is the ID assigned by Firebase, our external auth provider. And we're going to look into using the user session repository. We're going to look in the database for the user with that external ID. And if it's null, we're going to create a brand new user that represents that user, insert it, and commit it. Otherwise, we have our user, and in either case, we're going to end up setting our user property to expose that user. So as we talked about, this user session repository is using a different iUnit of work than the overall request iUnit of work, because we may end up committing it here before the request even fully starts getting processed. So, all right, we're going to load our user session there. And what we have to account for is the situation where the ID token is null. So there might be certain endpoints that we want to support when that do not require any sort of authentication. They might be allow anonymous requests. So we still want to represent that as a user session so that we know what situation we're dealing with. So we're still going to get the user session. And this time, though, we're just going to say load anonymous user session. All right, and then finally we're going to say await next.invoke. So we're going to call whoever's next in the middleware pipeline, and that's our custom middleware. So again, the whole point of this guy is to take the ID token and convert that into an actual user, so that on the user session now we can actually have access to whoever's making the request. All right, so we got our custom middleware in there. Next thing we want to do is make sure that we have support for AutoFact. So in my project here, I'm using AutoFact as the dependency injection library. So there's a couple things that we need to wire up to inform ASP.NET that we want to use the AutoFact. And then we're going to end up actually registering some modules. They're called modules in AutoFact to that's where you basically wire up your dependencies. All right, so first things first, we need to let ASP.NET know that we want to use AutoFact as our dependency injection library. So down below here, we can come in and we can say builder host use service provider factory. And what factory do we want to use? Well, we want to use the AutoFac service provider factory. Let's see if IntelliSense, yes, is going to pick up on the, which specific package we need to install. So there's another NuGet package we need here, the AutoFac extensions dependency injection. So we can install that. So now it will use AutoFac for our dependency injection. And what we need to do is inform ASP.NET how we're actually going to build the actual dependency injection containers. So we need to, and we haven't done this yet, we need to create what in AutoFac are called modules that are going to tell it how to wire up. Okay, when this particular interface is asked for, what concrete implementation should it actually return? So we're going to come into our infrastructure library here, and then right in the root of the infrastructure library, we're going to create a new file, new class, and this is just going to be shared module. All right, so we have a shared module, and the way AutoFac works, we want to inherit from module. So we have a couple different references here. We want this one from AutoFac. And this will be a public class, and this is where we're actually going to wire up our dependency injection. So what we do for that is we override a protected method called load. All right, so in our load method, there's a bunch of things that we're going to need to wire up here. First thing we can do is wire up from MartinDB, our document store. So we're going to register. We need to get a reference to our configuration so that we can eventually get from our configuration the connection string that we're going to use for connecting to the database, which MartinDB requires. So we're going to get iConfiguration, and then from that we're going to create a document store, which is the main information we use for letting MartinDB know how to actually talk to the database and set various settings on how we want it to interact with the database. So we are going to set some options here. And so we need to set our connection string. That's going to come from our configuration, and we'll have a connection string called main. Whoop, sorry, parentheses. And then in terms of serialization, we're going to be using MartinDB to basically use Postgres as a document database. So we have to define what options we want for serialization when it goes to serialize the object. So we're going to use Newtonsoft, and then within Newtonsoft we're going to say non-public members, because we want to let it know that we are, as we saw in our videos when we were creating our non-public setters. When we were creating our domain objects, we saw that each of the objects exposed properties where the getter was public but the setter was private. So we need to let Newtonsoft know from a serialization point of view when you're pulling something out of the database and you want to hydrate an object that the setters are not public. That way it knows to use reflection to set those. And then one other setting here, which is how do we store array values. So if we have an array, a list object on a particular object, when we go to save that, we want to store that as an array, a JSON array essentially. All right, so we've got our document store. And we also need to now document store apply configured changes to the database async, which is going to make sure that when the app fires up, and this is running for the very first time, that we actually make we apply any necessary document changes or schema changes to the database. And then final step is to actually return the document store that can be used. The next couple of registrations are much more straightforward. They're basically whenever you request an interface, we want to return a concrete. So we're going to do that for our domain event dispatcher, our user session, and our user session repository. So register type, domain event dispatcher, and we're going to return that whenever somebody asks for an iDomain event dispatcher. Come on, get a reference there. Okay. The other thing I mentioned is we want to do this for the user session. So whenever we ask for an iUser session, we are going to return a user session. And what we want to do here, though, is we want to say instance per lifetime scope. So what that means is we're going to get an iUser session per lifetime of the dependency injection container, and the lifetime of the dependency injection container is per request. So however long it takes to fulfill a request, we're going to have one dependency injection container per request, which means that this essentially is registering iUser session to be per request. So if we ask for it multiple times within the context of a single request, we're going to get the same user session back every time. And this is the user session that we were just looking at, that we're going to grab at the beginning of the request via our custom middleware. We're going to grab the user session and load information about the user that's making the request, so that future downstream classes that then ask for the iUser session to be injected within the context of the same request will be able to access that user information. All right, so next we're going to do builder register type. And one thing I should mention here is if we don't specify a lifetime, like on the other guys we have not, we only so far on the iUser session have registered an instance per lifetime. If we don't specify anything, it means create a new instance each time we ask for it. So that's the default behavior on anything where we haven't specified it. Just need to add there. So whenever we request an iUser session repository, we're going to get the user session repository back. And then we got two more things we need to register, and they're both related to the iUnit of work. So as we've talked about, there's going to be two units of work, one that is used for the request as a whole. The other one, though, is a much shorter-lived unit of work, which is really used at the very beginning in our user session launching. So we need to register both of those types. And we'll do the per request one first. So we're going to need a document store, which we're going to get from, we're going to resolve that from our dependency injection. And we also need a domain event dispatcher, which we're also going to get from our dependency injection. And what we want to wire up or create at that point is an actual unit of work. And our unit of work takes in the document store and the domain event dispatcher. And then we return the unit of work. Now, like our user session, we want this to be per request. So in order to get per request, we're going to get instance per lifetime, which again is the lifetime of the dependency injection container, which is per request. And then we need one more unit of work, where this unit of work is going to be exclusively used by the iUser session logic that we were looking at before. So again, we need a document store. In fact, I'm going to save myself some keystrokes here. There. And in fact, even the return statement is going to be the same. There's going to be one subtle difference. So even this will be the same, where we're saying it's per lifetime, so per request. And here comes the difference. We are going to use a feature of AutoFac where we can name a particular instance. So if a class asks for an iUnit of work to be injected and it doesn't specify a particular instance name, what it's going to get back is this unit of work here. However, if a class asks for this particular instance of an iUnit of work to be injected, it's going to get this unit of work here. And so if we do a quick search here, you'll see, as a reminder, that we have used that over here. So in our user session, where we might be doing some work in the load, right? Depends on whether or not we already have the user in our database or not, but we might have to create and insert and commit that new user. And in that case, we want to be using the user session unit of work. Hence, this is where we are specifying, hey, give me this specific iUnit of work. All right, so we've got all of that wired up, and we've got everything we need in our shared module here. So again, we've created our shared module, inherits from AutoFac module, and this is where we wire up our dependencies. And all of that was to serve the purpose of, back in our program here, we need to register that module. So then AutoFac knows where to look for any dependency injections when it starts that it needs to wire up. So we're going to say builder register module, and what we want to pass it is a new instance of shared module. Make sure we got our name right. Yeah. Okay, probably just don't have a dependency yet. There we go. So we need to add our reference, and now it's going to, so when the app starts, it's going to look at the shared module to figure out what dependency injections to wire up from there. Okay, now we need to do a very similar process for our products world. So in our catalog infrastructure, we are going to come into the products folder, and here's where we already have our products auto mapper. We're going to create another module here for AutoFac purposes, and we're going to call this products module. And what we need to do here is a very similar exercise of just wiring up our dependencies. So in our products module, the main thing we need to wire up, public class, inherit from module. We need to override our load method. And what we need to register here is our repository. So we're going to register a type. And whenever we ask for an iProduct repository, we're going to return a product repository. Fix our reference here. So whenever we ask for an iProduct repository, we're going to return a product repository. Perfect. Okay, now we also need to come back here and do the same thing here where we're registering that module. Make sure we get our reference. Looks like it's not recognizing it just yet. Come on. There we go. All right, so we're going to add our reference here, and we've registered our products module, so it's going to wire those up as well. Okay, so now we've done AutoFac. One other thing that we're using is allowing AutoFac, we want to allow AutoMapper. So when we are actually building the mappings between various classes like business objects and DTOs, we want to be able to use dependency injection in those mapper classes. So we haven't created any mapper classes per se, but if and when we do, we want to take advantage of the dependency injection. So one other thing we're going to add here in our program file is letting AutoFac know that it should be used for AutoMapper as well. So we're going to say builder register AutoMapper, and here's where we need to pass a reference to an assembly of what to scan and wire up and let AutoFac know about, so that it can provide dependency injection to any classes that are related to AutoMapper there. So in order to get rid of our error message, we also need to add a dependency here. And that dependency is going to be the AutoMapper. It's a contributed library here. So let's go in and manage NuGet. We're going to browse for this guy, AutoMapper contrib, AutoFac dependency injection. So again, this is allowing AutoMapper to take advantage of dependency injection. And if we come down here, we should get a ability to add our using statement. So perfect. So we've wired up our dependency injections for AutoMapper and our custom dependency injections within our shared infrastructure library and our products infrastructure. So next we're going to wire up Mediator. We've talked about Mediator a little bit. It's going to be used as, essentially, it's a pub sub in memory. So it's not going to be used to communicate per se right now between microservices, but within a microservice, when a request arrives, we're going to use Mediator to take that request and route it to whoever the appropriate handler is. So as we built out here, we have our command handlers for creating a product, updating a product, and we also have a handler for getting a product. So we're going to use Mediator to wire all that up, and we want to add Mediator support within the framework itself here. So to add the Mediator support, we're going to, under here, we're going to builder.services.add Mediator, and we've got to configure it. So we are going to say register services from assemblies, and we're just going to look for our products module. Any class within that assembly would be fine, and we're telling it where we want to look. Sorry, this has got to be an array. This thing, nice square bracket. There we go. So we're telling Mediator when the application starts, look for any Mediator relevant classes within this assembly. And it's looking for, just as a reminder, cases where we've implemented the iRequest interface and the iRequest handler interface. So during startup, that's what it's scanning for. So we just got to reference that assembly and tell it where to look for those interfaces and keep track of those. All right, so we've added Mediator support. Next, we're going to add a health check. So it's always a good idea to have a health check that we can reference, especially if we're deploying to the cloud. So we want to take advantage of ASP.NET Core's health check capabilities, which are pretty straightforward to add. We're going to come up to the top here, and we're going to say builder.services.add health checks. And then the only other thing we need to do is specify the URL that we want to actually map or have listening for our actual requests coming in for a health check. So question is, where do we want to put it relative to the authentication pieces? We can add it here above. So now we've added our health check, and we're listening on the endpoint of health. Okay, so we've added our health check, and now we want to add controller support. We're finally going to get to the piece where we're wiring up the mediator components to actually call controllers that we're going to create. So we're going to create a controllers folder. New folder, controllers. And under here, we're going to add our first controller, which is going to be our products controller. All right. In our controller, we want to, out of the gates here, what we want to support is basically get by ID, create a product, and update a product. So we're going to take our class. First thing we're going to do is we're going to declare it as an API controller. And I'm going to specify the route as products, all lowercase. And we want to make sure that it's only authorized requests that are hitting these endpoints. And one of the things we're going to inject here is iMediator. So again, mediator is what we're going to use to actually route the requests when they're coming in. And the first request we can add here is going to be our get by ID, where this request is going to return get product by ID response. Right? So we are going to take in as a GUID the ID that's going to come in via the URL. And then what do we want to do with that? Well, we want to use mediator to basically send that to a request where we're just going to be passing in the ID. And that's where the pub sub really comes in. So again, at the beginning of the app, via what we wired up in our program CS, it's going to be scanning the this assembly here, the catalog infrastructure, which means it knows about get product ID response, get product ID request, who handles it, and what that handler returns, and therefore our method becomes that simple essentially. So the next thing we want to do is we want to be able to support the creation of a product. So we're going to, in this case, be returning create product response. And this time we're going to get a create product request in the body of the overall request. And what do we want to do with that? Well, we want to, again, use mediator to send that off to be handled. And then finally, the difference between our create and our update will be that update uses a put. So we're going to get an update response back. And sorry, I'm going to update this. What we want to do is receive the ID of the product that we're going to update. We could either receive it in the body of the payload that comes up and not have an ID in the URL, but I prefer to have the ID in the URL here. So we're going to, it's going to be product / the ID, and that's going to represent what we want to update. And then even if they've sent an ID in the body, we want to override that with whatever ID we got here. And again, we issue that out to mediator and our controller's done. So using mediator I really like because it makes the controller decoupled from whoever is actually handling the request, but also makes the bodies of the controller methods really straightforward and pretty simple. So okay, we've wired up our controllers. Now we need to add support for controllers back in our program CS. So we want to add controllers. We can do that below our we can do it right here. We can say builder.services.add controllers. and then we're going to need to wire up through mapping the controller. So we don't need this guy here. And we're going to say map controllers, which will cause it to scan our controllers and looking for anybody that implements these attributes, and then figure out the routes based on our routing information here. All right, so we've taken care of all of our controllers, the dependency injection. We've covered a lot of different things here. So a couple last things that I want to add to our app is I always like to add the HTTPS redirection. So if somebody does make a request on HTTP, we redirect them automatically to HTTPS. And then we want to make sure we are using authentication and we are using authorization. All right. One other piece we need to wire up here is setting our app settings. So as a reminder, in our program CS here, we're going to be accessing a section called JWT, where we're going to get the authority and the audience to validate the JWT against. And then also within our shared module is where we're going to be accessing our connection string. So we want a connection string called main that we're going to be getting out of our app settings. So if I come over to the development app settings here and basically just copy in what we need here, the information in the JWT section around the audience and the authority you can get from the Firebase project. So the name of the project is what the audience will be, and then the authority is secure token google.com / then whatever the name of the project is. So I'm going to take this off screen and just paste in my connection string for the database. And so I've pasted in my connection string into my app settings. I'm going to close the files, and now if we go ahead and fire this up and bring over my browser here, one thing you'll see is that we didn't tell it a specific endpoint to open when we fired it up. But if I go to my Swagger, you can see here we've got our Swagger interfaces, so everything seems to be wired up and working properly. In our next video, we're going to create some Postman queries that we can use to actually start calling these endpoints to test them out and make sure they're working properly.
Time for a shameless plug for my personal LLC, Keystone Code. I've been doing software development for 20 plus years now, and I've been lucky enough that I've played a lot of the different roles that go into software development, from back-end developer, front-end developer, full-stack developer, team lead, head of engineering, chief technology officer, business analyst, and architect. So if your agency or company has any needs across those different areas, whether it be a need from just understanding what those roles are, or have a need to fill one of those roles, either from a training perspective, a mentor perspective, or an actual hands-on perspective, feel free to reach out. So I can be reached at my email address, dmichael@keystonecode.com, or on the website at keystonecode.com. Thanks.